All right, so this is just division. So I could have just as easily written it out across, where as we did it before. I think we did one of these, but you're going to keep change flips. You're going to take that top one. You're going to leave it the way it is. Oh, that is really thick. We'll take that down some. So we're going to say leave it x squared minus 1 over 5x. I will say we're going to factor it. X squared minus 1 is a special case. It's x plus 1, x minus 1 over 5x, which cannot be simplified anymore. And then we are going to multiply that. Keep change it to multiplication, and then we're going to flip this guy. So now the 10x is going to be on top, and the x plus 1 is going to be on bottom. And everything's factored, so now we can start canceling things. The x plus 1 and the x plus 1 will cancel. The 5x and the 10x will cancel to 2. So we don't have anything left on bottom, and on top we just have that 2 and that x minus 1, which is where we get this answer here. So again, we're going to keep change flip, meaning we're going to leave this as 1 over a plus b. And then we're going to change it to multiplication, and we're going to flip this one. We're going to factor this. Factors of 3 that add up to 4. That's just 3 and 1. So we're going to say a plus 1b and a plus 3b. And then the a plus 3b is going to go on bottom. And now we have factored everything. We can start canceling. The a plus b and the a plus b cancel. Remember, when you cancel, it just becomes a 1. And then the a plus 3b and the a plus 3b will cancel. So you have 1 times 1 times 1 over 1 times 1, which gives you that answer there. So we have done just basic simplifying, and we've done multiplication and division, which is pretty much, for all of that, you're factoring and canceling common factors. All right? For adding and subtracting, you have to go back, way back in your brain to when you first started adding fractions. What do you need in order to add fractions? What's required to add fractions? A common denominator. And once you get the common denominator, you don't add the denominator. You just add the numerators, okay? So once you have your common denominator, you just add your numerators. Why is that? Well, if I have 5/3 of something, like say a pizza, and I add 2/3, I'm not going to then have 7/6, right? I'm going to have the 5 pieces of the 3, the 2 pieces that was cut into 3. I'm going to have 7 of a third of each pizza, right? 7/3. And so once you get a common denominator, you don't add the denominators. That is your denominator for your final answer. You just then add your numerators. And so we're going to take that concept and we're going to put it into rational expressions, meaning we're no longer looking at just a number over a number. We're looking at a polynomial over a polynomial. But for the same reason as regular fractions, your polynomials have to have the same denominators. So they have to have common denominators. You'll notice they want us to add these 2 expressions here. All right. The first thing we're going to check when we're adding something like this is my denominator the same? X minus 2, x minus 2. Yes, my denominator is the same. And so I automatically know that my denominator of my answer is going to be x minus 2. And then from there, I'm just adding, in this particular case, I'm adding the x minus 9 plus the 3x plus 1. All right, I'm adding these 2. I'm only putting parentheses around these just for you to get used to it, because subtraction is imperative that you do parentheses because you have to subtract everything. With addition, though, it's a 1 in front, so we really just add our like terms. I'm going to say x plus 3x, that's going to give me 4x. And then I'm going to say negative 9 plus 1 will give me negative 8. Now, I always want to do this in factored form. The reason I want to do this in factored form is going to tell me if I can simplify. So this takes us all the way back to section 1. The reason I'm going to factor this is I'm going to look to see if anything cancels. It's just like a fraction. If you had this fraction right here, you wouldn't leave that as your answer, right? You'll notice they did something. They took out the common factor and canceled it out. The common factor was 2. right? So they divided everything by 2 and simplified that fraction. We're going to do the same thing. We're going to look at this and we're going to say, well, this numerator can be factored. What can come out of 4x and 8?
2. Oh,
so one more larger, 2 can come out, but we can take out a 4, right? And so I'm going to take a 4 out and have x minus 2. And on bottom, I have x minus 2. And once I do that, I can see I actually have something that can cancel. What can cancel in this? Yeah, the whole x minus 2 can cancel, and my final answer here is just 4. All right? And so when you're adding rational expressions, you need a common denominator. Once you have that, you're just adding your numerators, and then you want to simplify. See if you can factor anything out and simplify. So common denominators are also known as least common multiples. This is what you would have called it when you were in maybe middle school, least common multiples, all right? And so what you're looking for is you're looking for the smallest thing that they both have in common, all right? The smallest thing that you can put them both into. And so when you do it with numbers, then you just say, okay, what are all my factors? I'm going to use the minimum of my factors. And you do the same thing when you do your variables as well. So let's look at this first one. It wants me to find the least common multiple of each of these. The easiest way to do this is to make sure it is completely factored. So I typically write them in primes. So if I take this 27a, I'm going to write it as primes. So the way I'm going to do this is I'm going to say, well, that's 3 cubed times a. All right? I'm going to write it all in primes. I'm going to do the same thing with the 12a cubed b squared. And I'm just going to do this again in prime. So this is 2 squared times 3 times a cubed times b squared. And then I'm going to do the same thing with the 18. I'm going to say, well, 18, a to the 4th b. And I am going to do my factors here. So that's 2 times 3 squared times a to the 4th times b. All right? In order to get a least common multiple, I actually have to use the highest one of each of my terms to make sure that I have included all of it. Think of it this way. If I have 2 and 4, which is 2 squared, right? My least common multiple would be 4, right? I don't go down. I have to say, what would it be multiplied by? Okay, the least I can multiply by is 1 to find a least common multiple. So when I'm doing this, I have to get my largest of my multiples or largest of my primes. And so I'm going to look and I have a 2. I have a 2 squared and 2 to the first power. I have to use 2 squared. The next one, I have a 3. 3 cubed, 3 and 3 squared. I have to use 3 cubed here. All right, those are all of my numbers. So far, that's all of my numbers, right? Then I look at my variables. I have an a to the first, an a cubed, and an a to the 4th. I have to use a to the 4th. Then I have a b squared and a b. I have to use the b squared. And so this is how you would find a larger least common multiple. And then you're just going to simplify it. So 2 squared times 3 cubed, that's 4 times 27. And then you have a to the 4th b squared. That is my least common multiple of this particular one. So with numbers, we factored and we found all of the factors. With expressions, we're going to do the same thing, all right? So I'm going to take this first one and I am going to factor it. What can come out of x squared and 4x?
X.
Just an x. So I have x minus 4. X minus 4. For this one, I'm going to look for factors of 8 that multiplied or add up to give me 6. So I'm going to say, well, that's going to be x minus 4 and x minus 2. All right? And then I have to use one of every one of my factors. And if I have a repeated factor, I have to use the highest one of those. So I have to use an x. All right? I have an x minus 4 and an x minus 4. They're both to the first power, right? They're both to the first power, so I need an x minus 4 here. And I have to use the x minus 2. You'll notice that I'm underlining it to make sure I got each one. That would be my least common multiple. I don't have to do x minus 4 2 times because they're both only used once. If one of them had been squared, so let's say I had x minus 4 and x minus 4 squared, then I would have had to use the higher one. But I only have to use each term once. It covers them both. And so this would be my least common multiple of something like b. All right, so now they want us to add these two expressions, all right? Remember, the first thing we're going to do is we're going to check to see, do we have a common denominator, all right? In this case, we do not. We have x squared plus x minus 6, and we have x squared minus 4x plus 4. So once we realize we do not have a common denominator, we are going to factor all of our denominators and see what we have in common to get our new denominator and what it should be. So we are going to look at the first one. We're factors of negative 6 that add up to 1. So this is going to be x plus 3, x minus 2. All right. X plus 3, x minus 2. Positive 3 times negative 2 is negative 6. Positive 3 plus negative 2 is positive 1. So here's my factoring. For this next one, x squared minus 4x plus 4. That's just x minus 2, x minus 2. And another way to write this is x minus 2 squared. Okay? Right? So I am going to look at my common factors here. And I'm going to say, well, I have to use at least one of each thing. And if something is to a higher power, I have to use the higher of the two powers. So I know I'm going to use x plus 3. And I know I'm going to use x minus 1, but this is x minus 1 to the first power, and this is x minus 1 to the second power. So I have to use the higher of the two, all right? Another way to look at it is it has to be a 1-to-1. So I need an x minus 2 here, x minus 2, and I still have 1 left over. So I know I'm going to have to do x minus 2 to the second power here. That will be my common denominator. That will be my common denominator. Now for my numerator, I have to multiply my numerator by what it's missing, all right? So I'm going to look at this first one here, 5x, all right? 5x. We're going to compare what was originally under my 5x to my common denominator. My 5x has the x plus 3, right? And it has one of my x minus 2's. What is it missing? Compared to my common denominator, what is it missing? It has an x plus 3 and it has one of the x minus 2's. What does it not have? The second x minus 2, right? So that's what we have to multiply that by, x minus 2, right? Let's look at my next one. We're going to look at the x plus 7. My x plus 7 has the x minus 2 squared. What is that one missing from my common denominator? It's missing the x plus 3.
I thought that was wrong.
Does everybody see that? All right. So we're going to compare what was originally under it to my common denominator. All right. The 5x has the x plus 3. All right, so they have the x plus 3. And it has 1 of the x minus 2's. So I had to multiply it by 1 of the x minus 2's. All right? For the x plus 7, the x plus 7 has the x minus 2 squared, but it was missing this. So I had to multiply by what it was missing. You're just multiplying by what it's missing. All right? And then once you have that, you're just simplifying. You're distributing or foiling and then simplifying. So from this point, I am just going to distribute here. 5x times x, that's 5x squared. 5x times negative 2 is negative 10x. All right? Then I'm going to FOIL the next guy. X times x, that's x squared. X times 3, 7 times x, and then 7 times 3. All right? So on the top there, I am just distributing or foiling. On the bottom, I'm going to leave it alone. I am not going to distribute. I'm not going to FOIL. I'm going to leave it in factored form. All right? Once you have this, you're literally just simplifying, combining my like terms. All right? And so I am going to have the 5x squared. And we're going to go ahead and simplify it. 5x squared and 1x squared will give me 6x squared. Negative 10x plus 3x plus 7x. What happens there? Negative 10 plus 3 plus 7 will cancel. That's a negative 10 and a positive 10, right? And then I just have a 21 plus 21. And then on bottom, I still have my x plus 3 and my x minus 2 squared. What do you think I need to do on the top? What can come out of the top?
3.
What do you think? Yeah, a 3 can come out, right? So we can say 3x squared plus 7, x plus 3, x minus 2 squared. This is how you actually want to leave it. Even though it didn't help you to take out the 3, this was a 2, by the way. It didn't help you to take out the 3. You still want to check it and make sure. Just in case you could have canceled something with that denominator, you want to leave it in factored form. And so this is your final answer here. All right? That's your final answer. And so to go through the step-by-step process, your first step is to find your common denominator. So your least common denominator, that's what you're looking for first, all right? And you want to write that down. So we wrote it down here. And then you want to take each numerator and multiply it by what you're missing. So what is missing from the common denominator? That's how we found that, okay? We found our common denominator. We said, okay, he has the x plus 3. He has the x minus 2. He's missing one of the x minus 2's. For this one, he has the x minus 2 squared. He's missing the x plus 3. That's how we figure out what we multiply each numerator by. And then from that point on, you are just simplifying. Simplify. That means you may have to distribute. You may have to FOIL. Combine like terms. And then you may have to factor and cancel if possible. Cancel if necessary. All right? So that's what simplify is going to mean. It's going to mean distribute, FOIL, combine like terms, factor it, and see if you can cancel anything out. All right, let's look at this one. This one is very, very close to common denominators, right? So what would we do here if we were canceling? What would we notice about those denominators if we were canceling factors that looked like that?
Denominators, well, basically.
These are opposite factors, right? Do y'all remember opposite factors? Right, someone said it. There's a negative. And so for opposite factors, you really don't have to go through the whole process. All you really have to do is take out that negative. So we have the 5x plus 4 over x minus 3. 3x minus 1 over, and I'm going to pull a negative 1 out. When I do that, my negative x becomes a positive x. My positive 3 becomes a negative 3. So taking a negative out of an opposite factor will make it just like the other guy. All right? I don't even really have to consider that negative in my common denominator. Here's why. I can actually just apply it to this. All right? I can just apply the negative up there to that group. So I can just say, well, instead of having that negative on bottom, we'll just put the negative on top. Like that. That will work. It works the same. All right. The other thing you can look at is because it's in front of the entire group, I have minus a negative. What happens when I minus a negative anywhere? It becomes a plus, right? And so I can literally just say plus a positive. That's going to fix my problem. So now I'm adding 2, and I already have a common denominator, right? And so my denominator is going to stay that x minus 3. And then I have 5x plus 4 plus 3x minus 1. Like I already have the common denominator, and I'm just adding. And so at this point, I can just combine my like terms. 5x and 3x, that gives me 8x. 4 minus 1 gives me 3, and it's over x minus 3. Can I factor anything? Do 8 and 3 have anything in common? They do not. The bottom is already factored as much as possible. This is my answer. I am done. So just because it looks like subtraction, if you can pull a negative out, it actually is just like subtracting a negative. It's the same concept. So the first thing I'm going to do is I'm going to check my denominators. Are they the same? Clearly they are not. So I have x squared plus 11x plus 30, and I have x squared plus 2x minus 24. I'm going to factor. Factors of 30 that add up to 11, what are they?
3, 8,
5 and 6, right? 5 and 6. Factors of 24, specifically negative 24, that add to give me a positive 2. I'm going to have a positive 6 and a negative 4. All right? And then I need my common denominator. I know I'm going to have to use an x plus 5. So that's going to be part of my common denominator. I'm going to have to use an x plus 6. Those are both to the first power, so I only have to use it once. And I know I'm going to have to use an x minus 4. So my common denominator is that big thing right there. That is my common denominator. All right. For my numerator, I'm going to start with the 4x plus 2. 4x plus 2. All right. The 4x plus 2 has the x plus 5. It has the x plus 6. What is it missing?
X minus 4.
The x minus 4. That's what I need to multiply by. X minus 4. All right. This is now subtraction. So I'm going to put this, make sure you put the correct operation. Let's look at the x minus 1. We're looking at this one. X plus 6. We have the x plus 6. X minus 4. We have the x minus 4. What is this missing? The x plus 5. All right, does everybody see why I'm making notes and marking it so that I can see clearly what I'm missing? All right, so that's what it looks like at this point. I now just need to FOIL each one of those, all right? So I'm going to FOIL the first one. So I have 4x squared minus 16x plus 2x minus 8. That's my first group. all right? Put subtraction there. Make sure you put a grouping. X squared plus 5x minus 1x minus 5. All right? So far, so good. You can simplify in here if you want to. So we have negative 16 and positive 2. That's negative 14x. 5 and negative 1 is positive 4x. All right? We are, at this point, going to subtract. All right? So this is why I put grouping around it. I'm still just working on my numerator here. My denominator is not going to change. So when I combine like terms, I have 4x squared minus 1x squared. So what do I have there? 4x squared minus 1x squared, 3x squared. I have negative 14 minus 4. Yeah, so negative 18x. And I have negative 8 minus a negative 5. Negative 8 minus a negative 5. So I have what?
Negative 13.
My bottom actually stays exactly the same. I'm not going to change anything about it. I'm going to say the x plus 5, the x plus 6, and the x minus 4. All right? Can I factor anything out of the numerator? Can I factor anything out of the numerator?
3.
Yeah, I can take a 3 out. So I have 3 on the outside, x squared minus 6x minus 1. Are there any factors of 1 that add up to give you 6? Yeah, 1 and 1. I mean, you're never going to get 6. So the top is not factorable. This is actually all you can do with this one. This one's done. That is as simple, even though it doesn't look simple, as it gets. That's as simple as you can do that one. Find your least common denominator, rewrite it with it. So rewrite it with that. See if you can reduce anything, like on that first one when we're added. If you rewrite it, you can actually reduce before you start, just like any other fraction. So if you see that once you factor your denominator, you can actually reduce it with its numerator before you start adding and subtracting, go ahead and do that. It'll make it easier. Add or subtract your numerators once you get your least common denominator and simplify it. All right, we have something like this. So we did one similar to this for bell work, but for bell work, everything was over the other fraction. In this case, we have what's called a complex fraction, meaning it's not just a simple keep, change, flip. We actually have two fractions on top pretty much that don't have common denominators and fractions on bottom that don't have common denominators. And so the easiest thing to do here is actually to find your common denominator amongst every single term and then multiply every single term by your common denominator. All right, and so I'm going to look at each one of these. My denominator of my 5 is just a 1. My denominator here is x. My denominator of my 25 is just 1. My denominator here is x squared. So between those four denominators, I have a 1 under my 5, an x, I have a 1 under my 25, and I have an x squared. Those are all my factors of every single denominator I have. So what is my common denominator amongst these four?
X squared.
Yeah, just my x squared. You don't even have to list the 1, right? My x squared is my common denominator. And so what I'm going to do is I'm going to multiply every single one of my terms by x squared. So I'm going to say 5 times x squared plus 1 over x times x squared. Put it like that so you can see it. 25 times x squared minus 1 over x squared times x squared. All right. What this does is it gets rid of all my denominators, my original denominators. So I have just a 5x squared there. Here, this is over 1. So what is x squared times 1 over x? What happens there? I can reduce an x out, right? So I can reduce one of those and I just have an x. On bottom, I have 25x squared. And then this becomes just a 1. All right, that becomes just a 1. I want to factor these. Can I factor the top? Can anything come out of 5x squared and x?
X.
Yeah, just an x. And I have 5x plus 1. This is a special case. What is that guy? 25x squared minus 1. Special case. Perfect squares, right? So I can take the square root of each one. 5x plus 1, 5x minus 1. What can I do? I can cancel. And I'm left with just an x on top and a 5x minus 1 on bottom. And that is my answer. So when you have a crazy big complex fraction, you just want to find your least common denominator of all of it and then use that to cancel. All right, use that to cancel.